back.
Knowledge.
Good afternoon. Are you ready to get some?
Knowledge.
Let's do it. All right, so this is continuation from the previous video's lecture, and I want you to title this section, Using the Properties of a Transversal and Parallel Lines. You're going to see the screen flicker a moment. I'm going to make the writing bigger for you. There you go. All right. You don't need straight edge or ruler. These drawings can be as sloppy as you like them to be. I need you to please draw 2 lines and a transversal. Now, these past couple days, we haven't cared what the relationship is between those 2 lines being intersected. We just said these are 2 lines and they're being intersected. And we were looking at the angle pairs that got formed, right? Bless you. Yesterday's lecture was all about talking about the relationship that those angle pairs get into when we force these lines being intersected to be parallel. So I want you to mark your drawing with those lines forced to be parallel. Notice the extra arrowhead. That extra arrowhead means those lines must be parallel. All right. And then mark this angle with a measure of x and this angle with a measure of 2x minus 1. And the directions for this example are find the value. Yes.
Anita Londra Acevedo to the library, please.
Thank you. Find the value of x. All right. The first question you need to ask yourself is, what angle pair are we looking at? So the first important question is, what's the angle pair? All right, well, I've got this angle here and this angle here. My transversal Uno players,
Yes.
what's that angle pair named? Corresponding.
Yes.
Chip. So these are corresponding angles. And according to yesterday's notes, corresponding angles are said to be congruent. What does congruent mean?
Same size.
Same size, same shape. Which means that their measurements are a different word than congruent, because we're talking about numbers now.
Same.
The same, and the mathy word for the same is? Starts with an E. Equal, or equivalent, yeah. So their measures are equal, which means in our weird symbol math algebra language, we can rewrite this as this angle's measure. I don't know what it is, but I'm going to use the symbol x because that's what it told me. Equals this angle's measure. Again, I don't know what it is, but the symbols tell me that it is 2 times x minus 1. And now we get to pretend it's straight up algebra and just solve the thing for x. All right, I'm going to agree with you that I already see it as x equals stuff, and that's one of the criteria, but some of the stuff is also x, and that's not helpful. We got to get all of the x's all together on one side, and then everything else on the other. So the first question is, which side of the which side of the equal sign do you want x to be on? The left or the right? The left, he says. Okay, so this is where I want x to end up, which means I have to get rid of this 2x. How do I do that? Yes. since this 2x is positive and being added and subtracted to the rest, I'm going to subtract 2x from both sides. When I do that, that's going to go away on the right-hand side, and here I'm going to be left with a negative 1x, and on the right-hand side of the equal sign, I'm left with just a negative 1. Now, how do I get rid of this negative 1 here? Plus 1? What's the operation happening between the negative 1 and the x?
It can be negative because the variable was
Right, we've got to figure out what the x is by itself. We can't have that negative 1 there. So the question is, what's happening between the number and the x? What's the operation? It's multiplying. Whenever you don't see an operation between two symbols, you assume it's multiplication. Okay? So we're going to divide both sides by the negative 1 because the negative 1 is what I want to get rid of. And so I'm left with x equals a negative divided by a negative is a positive, and so this becomes a positive 1. All right. Any questions on the algebra? All right. On yesterday's lecture, you're given a list. Hey, over here. From yesterday's lecture, you're given a list of angle pairs that are congruent to each other. And so if you're asked, find the value of whatever, and your angle pairs are one of the ones that are congruent to each other, this is what you do. Okay? Let's look at it again. So I'm going to put the symbol congruent so it's easy to find. And here I'm going to write the word supplementary because this is the example of what to do when your angle pairs are said to be supplementary to each other. Again, start off with two lines, cut by some sort of transversal. Okay? And again, we're going to mark that these lines are parallel. Now I'm going to zoom in really tight over here because, hey, Victor, taking notes. Yeah.
I finished her. Somebody gave me the paper to copy off.
To copy up? Okay. Then don't distract others, all right? Okay. All right. And now I'm going to write, I'm writing really small. I'm sorry, but bear with me here. 100 plus 2 times x, and over here is going to be 3x minus 20. And again, your directions are going to say, find the value of x. And again, the first question you should ask yourself is, what are my angle pairs? What angle pair am I looking at?
exterior angles.
Same side exterior angles. They are on the same side of the transversal and they are outside the lines being intersected. These are same side exterior angles. From your notes from yesterday, you will get told that same side exterior angles are supplementary. And what does supplementary mean? If you don't remember, if you forgot, you need to underline supplementary and put a question mark. And then, over here on the left-hand side of your paper, we are going to put that question mark again. Supplementary means adds to 180 degrees. If you couldn't remember, you need to write it down. That means that whatever those numbers are, if I add them together, I'm going to end up with 180. And so with algebra, this is what it's going to look like. This angle up here plus this angle down here equals 180. And now once again, it's just a standard algebra problem. I'm going to zoom back in again so that we're a little easier to see. All right, first thing that we could do is try to make this left-hand side look a little more simple. I'm going to do that by combining these two like terms and these two numbers. And I'm going to do that in the same step. I have 2 ex-boyfriends over here, and over the summer I had a really bad summer and I got 3 more ex-boyfriends. How many x's do I have now?
5x.
I have 5x. All right, and here I have 100 minus 20, 80. And since it's a positive number, I'm going to put an addition sign, plus 80. All right, now what?
Minus 80 to
Going to get rid of that 80 from both sides. When I do that, I'm left with 5x on this side, and over here is 180 minus 80, which is 100.
And divide by 5.
And now I'm going to divide both sides by 5. When I do that, this side becomes x, and this side becomes 100 divided by 5, which is, that was close, 20. Yeah, I heard it from a couple people. 20. Take a moment right now, and here in your little space on the right, fill in whatever you need to remember to get through that algebra. Take a few seconds right now. All right, ready to move forward? All right, so now when you're given a find the value of something, and it's in a setup like this, if you encounter the angle pairs that are listed as supplementary from yesterday's notes, you just do this to it, and you're done, okay? Very easy. All right, now I want to hand you something that is a little more thought-provoking. Gives you guys a little more knowledge. And so what I want you to do is title this section Proofs. This really is kind of the big part of this course. Yes, we're going to be doing a lot of shapes and measurements and things, but really, what did we do starting day 1 when we started content?
Angles.
We did a bunch of numbers, we did measurements and converting things.
We wrote our rules.
We wrote our rules. And what was the big thing that y'all really didn't like to do, but I asked you to do anyway?
Homework. Metric system. Homework.
Huh?
The metric system.
Okay, metric system. But in your work, look at those examples. I asked you to justify each and everything you did. What did you do? How did you do it? And why did you do it? Remember? That was setting you up so that you were ready for this. Because a proof is the formal way of saying, if I have a bunch of this stuff, then this other stuff will always happen. And here's the reason why I kind of am enjoying math, especially the geometries now. I didn't used to. But once I realized this thing that I'm about to share with you, I got to really enjoy it. What it is in math, I could make up anything I wanted. Even if it sounded really darn silly, I could just make it up. But if I found a way to explain how I got there, and my logic was sound, and my definitions strong, and I built it on definitions and logic that came before, then it's true. And if I can show that, it will always be true. For all of eternity, the rest of time, it'll always be true. Now here's the best part, is not only will it always be true, but from that moment that I proved it, it will always have been true.
Because of knowledge.
Okay? So that's what we're going to embark on in this course now. Okay? We were setting up this whole time getting ready for proofs. All right, here we go. Draw 2 lines cut by a transversal. They don't have to be parallel, and they don't have to look parallel, so don't mark them that way. But do label your angles with numbers 1, 2, 3, 4, 5, 6, 7, and 8. I would like it if you please followed my numbering scheme, just so that we're on the same spot. And I need 3 letters, please.
ABC.
I heard A, I heard B, and I heard J. I thought I heard an L too, and I'm very sorry for not picking that up quickly. I did hear it, but my brain grabbed B and latched onto it. I'm sorry. All right. So here's our setup. Notice the letters. They're lowercase and they're cursive. And they're lowercase and they're cursive because we're naming lines with them. All right? So make sure in your notes they're lowercase and they're cursive. All right. We are going to be given this information, which is like our hypothesis. If line B is parallel to line A, that's a cursive B, I'm sorry. So given that line B is parallel to line A, then prove that angle 3 is congruent to angle 6. Now in our notes from yesterday, when you watch the video, if you haven't yet, if you haven't, go back and watch it. It will tell you that these two angles, alternate interior angles, which is what those are congruent. It'll just hand it to you. The thing that I don't say in that video, that I'm clearing up now, is that statement, alternate interior angles are congruent, is a theorem. It's one of those things that someone made up and guessed and then went through and proved it. And so now it is true for all time, and it was always true even before he thought of it. And we are going to go through the exercise of creating that proof for ourselves. Okay? All right. So let's start off with what we're given. We're told that these are parallel. This is our start, and we're going to create a little mind maze. And we need to end our goal with saying that these two things are congruent. Okay, we're going to make a big mess, and then we'll clean it up at the end. If you're having trouble doing your essay writing in English, this tactic could help you. Okay? Offering help to you guys. All right. One of the freebies that we're going to get from the video from yesterday is that corresponding angles are congruent. It is one of the only ones that are freebies from yesterday's lecture, and it's because this thing is called a postulate. And postulates are one of those items that you get to say that's true and don't question it. This is mom saying, huh? Wash your hands? But why? Because I said so. And if you argue, the chancla comes off and she hits you in the face, right? Right?
Yes.
Right. So the postulate is mom going, because I said so. Here's the chancla. Okay? So we have to take that for granted. Look at the figure. Find your corresponding angles. There's 4 of them. 4 pairs of them. Do you see them? They're all congruent to each other. All right? All right. Now we're trying to get to angle 3 and angle 6. So can you list me one of the pairs of congruent angles that has either angle 3 or angle 6? 3 and 7. So because corresponding angles are congruent, we can say angle 3 is congruent to angle 7. All right? Mm-hmm. All right. So we've got half the puzzle done. The next part is, so we've got this one and this one. Now we've got to find a way to get 7 to connect to 6. Because if we can find a way to say that 6 is congruent to 7, then we can say that 6 is congruent to 3, because 7 becomes like our little bridge. Okay? Look at the relationship between angle 6 and angle 7. Does that look familiar?
Yeah, yeah.
What was that called? Do you remember? They may be obtuse, we don't know for sure.
Cute.
They could be acute, again, we don't know for sure. But this relationship, what was it called? And I hear people flipping through their notes, and I love that. It's not in that section. Keep going forward. I'll give you a hint. The name of this relationship starts with the letter V. Vector. Vector is not dealing with angles. They share a vertex, yes. One more time. Vertical angles. Angle 6 and angle 7 are vertical angles. Which means they're congruent. Because in that section, this is chapter 1, lesson 5. So I'll put a little note here. Chapter 1, lesson 5 is where this came from. When we looked at vertical angles, we had a sentence that said vertical angles are congruent. And so, because I now have corresponding angles, 3 and 7 congruent, and 6 and 7 congruent together will give me 3 and 6 are congruent. The big question is, why? What's the property that allows us to do this? To take two things that are different, 3 and 6, and say they're congruent to each other because they're congruent to the same thing. That makes sense, doesn't it? All right, here's the name of that property. You ready? It's the transitive property. Does that word sound familiar? A little bit, yeah. We went over it back in chapter 0, lesson 4 and 5, way early in the beginning of the year, so it's there. All right, we have our mind map. We have our mind map. Now, let's write our formal proof, just like writing the final draft of our essay. You ready?
Yeah.
All right, here we go. What I need you to do is cut the rest of your notebook paper into 2 vertical columns. You can make the right side a little bigger than the left. Give yourself a title space. Title the left part statements and the right part reasons. Does this look familiar?
T-shirt.
It's like a T-chart. Shh, shh, shh.
Laws.
Huh?
Laws.
The laws from this class, the very start of this course. Yeah, when you were asked to show your work on the left and your justification on the right, this is what you were being set up for. The first one is always the easiest. Are you ready? The first one is always the thing that you were given to start with. Which means if I drop one of these things on a test and if you don't get that one right, I'm going to be like, I give up. I'm going to flip the table and just leave because it's given to you. Okay? So please don't get that one wrong. All right. What was the next thing that we said after the given? So here's our given, our start. The very next thing was this thing about corresponding angles. That they're congruent, which gave us that angle 3 is congruent to angle 7. So our statement is angle 3 is congruent to angle 7. And the reason, the formal name for the sentence, corresponding angles are congruent, is the corresponding angles postulate. And remember that a postulate is just something that you're going to go on faith. It is the mom hit you in the face with the chancla and said, because I said so. Okay? So far, so good? All right. The next thing that was said was this thing here about the vertical angles, yes? Because we need this before we can connect it together. So this statement is here that the angle 6 is congruent to angle 7. And the reason we said that was because vertical angles are congruent. And here's the formal name for that sentence, vertical angles are congruent. The formal name is the vertical angle theorem. And notice that there's a difference between postulates and theorems. Remember, postulates are, Mom, because I said so, and theorem is the why. Okay? And someone found the why, and now it is true for all time. Now that we had those, we put them together using the transitive property. And we're going to use this one of congruence because that's what we've been using this whole time. There is a transitive property of equality too, and so if you're dealing with numbers and an equal sign, you'll use that one. We're dealing with congruences, so we're going to use the one for congruence. And this allows you to say that angle 3 is congruent to angle 6. Is that our prove line, what we wanted to prove? Look back at the top. What was the line for prove?
Yes.
Yes, because our prove line at the very top of the page says angle 3 is congruent to angle 6. We have that here as our statements. We are done. I don't expect you to be masters at writing a proof today. I expect you to go, this was kind of interesting. I'm ready to try again. And at the end of the year, you will be able to write a full proof like this completely on your own. Not today, but before the end of the school year in May. Okay? All right. Thank you very, very much.
Knowledge.